we have to check the consistency of the system of equations. As you have seen, what we have to check, we will find first what will be our working procedure, determinant of A. Okay. So if determinant of A is not equal to 0, if A is not equal to 0, then the system is consistent. I'll write in short, then the system is consistent system of equations. And if determinant A will be equal to 0, then we have to find two things. Means then we have two possibilities. We will find the adjoint A. Adjoint A is a matrix. Multiply with matrix B to get 0 matrix. Okay. If it is 0 matrix, we are getting 0 matrix on right hand side on multiplying adjoint A with B. Then the system of equation solution does not exist and system is inconsistent. Then its solution does not exist. When its solution does not exist, that means the system is, and the system of equations is inconsistent. Or inconsistent system of equations. Or if we get second possibility is if we get adjoint A, but after this is the first part, second part, this is second part. This first part, if we get 0, not 0, then it will get over there. If we get 0, then we have to check adjoint A and B also. So if adjoint A multiply with B is not is not equal to 0. First, here is not equal to 0, then the solution does not exist. And if it is equal to 0, then it is either may be consistent or inconsistent according as the system has infinitely many solutions or no solutions. So generally when we are getting 0, this is the system of equations will be consistent, but either infinitely many solutions or the system of equations will have solutions, but it may be infinitely many solutions. So system of equations is consistent. Only in this case inconsistent will come, otherwise consistent. So here we have to check. So first question, now we will do question number 1. We are doing question exercise 4.2, question number 1. X plus 2y is equal to 2 and 2x plus 3y is equal to 3. So what is A? A is the matrix of the coefficients of x and y. So here from before x there is 1, here y, 2, coefficient of x, equation number 2. This is equation number 1, equation number 2. Coefficient of x is 2 and coefficient of y is 3. So this is your matrix A. Now you will find its determinant. So write the determinant form 1, 2, 2, 3 and multiply 1 3 is a 3, then minus 2 2 is a 4. 3 minus 4 is equal to minus 1, which is not equal to 0. The value of determinant is not equal to 0, hence the given system of equation, hence it is consistent. System of equation is consistent. Okay. A is when A is not equal to 0, then matrix is singular. Non-singular, you can write A is non-singular, is not equal to 0, then A is non-singular. Also, you can write non-singular matrix. Okay. Like this, we have to do. I am not taking 2 by 2 matrix. I will take directly 3 by 3. Okay. So, if you see, we have question number 4, 5, and 6. There we have 3 by 3 matrices. In question number 4, you will have non-singular matrix, so is consistent system of equation. But in question how to start this one, I will take all the steps. In matrix, representation, we get matrix 3 minus 1 minus 2 0 2 minus 1 3 minus 5 and 3 A, and X is X Y Z always, because there are 3 variables here, X Y Z 3 by 3 matrices, and right hand side is 2 minus 1 and 3. So this is the matrix representation, or we can say this is A, so AX is equal to B. This you should write first, and then find the determinant, value of the determinant to get the condition. So 3 minus 1 minus 2 0 2 minus 1 3 minus 5 3. Find its value. They are expanding along first row. Okay. Along first row, 3 is common. Then 2 3 is 6, 3 times minus, so 5. Then this will be minus, so minus minus plus 1. Then this is deleted to 0, minus minus plus 3. Then plus means plus minus minus 2, deleted from this part. And 0 minus 2, 0 into 5 0, minus 3 2 is a minus 3 2 is a 6. So 6 minus 5 1, 3 plus 1 3, minus minus plus 6 2 is a 12. So we get the answer is 6 minus 5. Check again. 2 3 is a 6, then minus minus plus plus minus minus, then minus minus plus 0 into minus minus plus 3, then minus 2 minus 2 0 minus 6 and minus plus 12. So we get 18. We get 18. 3 minus 1 minus 2, 0, 2 minus 1, 3 minus 5, 3 minus 5, x, y, 0. This should be 0 actually. There is no z. So when it is 0, then we take minus, just check again. It will become 0. Okay. 3, 2 into 0, 0 minus 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 3 times 5, 2 into 0, 0, then minus minus plus 1. This row, this column is deleted, 0 minus minus plus 3, and then minus 2, 0 into 5, 0, minus 3 to the 6. So we get minus 5 3 is 15, plus 3 and minus minus plus 6 to the 12. So we get 0 here. Okay. When it is 0, now we have to find the adjoint A. In order to find the adjoint A, we need to find C11, C12, C13, all values. Okay. So find C11, C12, C13, C11 means power minus 1 raised to power 2 to positive. So C11 will be 2 into 0 and minus 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 5. C11 will be minus 5. Like this, C12 will be minus 3. C13 can find out will be minus 6. C21 will be 10. C22 will be 6. C23 will be 12. C31 will be 5. C32 will be 3, and C33 will be 6. So then you can find the transpose of the matrix of 4 factors. So C11 will come here. So we will directly write minus 5, minus 3, and minus 6. Minus 5, minus 3, minus 6, 10, 10, 6, 12, then 5, 3, and 6. This is adjoint A. Okay. Now we have to find the multiplication adjoint A with multiply adjoint A with matrix B. Okay. So adjoint A is minus 5, 10, 5, minus 3, 6, 3, minus 6, 12, 6. Multiply it with that with matrix B, that is 2, minus 1, and 3. Now you have to check whether you are getting 0 or not. So first row, first column, minus 5 into 2, minus 10, then again minus 10, and 5 3 is 15. You are not getting 0. Then for second row, first column, minus 3 to the 6, minus 6 plus 9. Third row, first column, minus 12, minus 12 plus 18. And as you know, this is 3 rows and 3 columns. This is 3 rows and 1 column. So answer will be 3 by 1, 3 rows and 1 column. So the answer will be a column matrix that will be minus 5, minus 3 and minus 6, minus 5, minus 3 and minus 6, minus 5, minus 3 and minus 6, which is not equal to 0 matrix. That is O. Capital O is the 0 matrix. The solution of the given equation does not exist. Therefore, the solution of the given equation does doesn't exist, hence the system is hence the system of equations is inconsistent. So this you have to do when A determinant A will be equal to 0. Determinant A is not equal to 0, then you have to stop there. If determinant is A is equal to 0, then you have to find the adjoint also. So like this, you can do other questions also. These are 6 questions. You can try all these questions. Question number 12. No, not 12. 14. Question number 14. 4.6. So these are the equations given. So we have to write the value of A and then find adjoint A and determinant A. So determinant A, you can directly find out determinant 1 minus 1, 2, or you can use Serres diagram also to find this minus 1, 3. For Serres diagram, do you remember 1, 3, 2, minus 1, 4, minus 1, 2, minus 5, 3, and then repeat 1, 3, 2, minus 1, 4, minus 1. 1, 2, 3, yes. Multiply these 3, 4 3s are 12. These 3 minus minus plus 5 2s are 10. These 3 minus will come 3 2s are 6 positive. And then in negative, multiply this 2 2s are 4, 4 are 16, and minus minus plus 5, and 3 into 3 into minus 1 minus 9. 12 plus 10, 22 minus 6, and minus 16 plus 5, 21 minus 9. So 22 minus 6, 16, minus 21 minus 9, 12. 16 minus 12, 4. So answer will be 4. So this is the value of the determinant we can find out by this way. Okay. So determinant is coming 4. So we can write here its value is 4. Okay.
Yes, sir.
Then up this part. Now we have to find coefficients C11, C12, C13. So find C11. C11, 4 minus 4 3 is 12, minus 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 5, 12 minus 5, 7. C12 means negative sign, taken out. 3 3s are 9 minus minus plus 5 2s are 10 minus 9 19. 3 13. 3 13 is this one. Delete this one multiply. So minus 3 and minus 4 2s are 8. So minus 11. Okay. So like this, you can get the adjoint 7 minus 19 minus 11. Similarly, in order to save the timings, I am writing directly C 21 22 you can find out, and then adjoint will come. So suppose we get adjoint as adjoint will be equal to 7 1 minus 3 and minus 19 minus 1 and 11 and minus 11 minus 1 and 7. You can check whether you are getting this or not. And determinant is 4. So 1 by 4. Adjoint is 1 by 4. Now we will substitute the value. X is equal to A inverse. A inverse means adjoint A upon determinant A. A inverse is what? Adjoint A upon determinant A. The determinant is 1 by 4 into this adjoint 7. 1 minus 3 minus 19 minus 1. 11 minus 11 minus 1 and 7. Okay. So this is A inverse. Substitute its value 7 1 minus 3 minus 19 minus 1 11 minus 11 minus 1 and 7 and multiply it with B. What is B? Value of B is right side. This 7 minus 5 and 12. So you will multiply first row, first column, second row, second column, third row, third column. You will get the row matrix, column matrix, sorry, 2, 1 and 3. Answer will be 2, 1 and 3. And this x, what is the value of x? X is x, y and z, and that is equated to plus 2, 1 and 3. So we can equate the corresponding element. Therefore, we got x is equal to 2, y is equal to 1 and z is equal to 3. This is the solution of the given equation. We have solved by matrix method these equations. This is equation number 1, 2, 3, and you can give the number 1, 2, and 3. Got it? So inverse, find inverse, multiply. At last, always you will get 3 by 1, and here also 3 by 1. X is what? X is always x by z. X, y, that is 3 by 3 is 2 by 2, x, y only. And B, you know that this is B, 7 minus 5, and substitute to get that.